Hello guys, and welcome back to the course. Today we are going to learn a new technique for determining the limit of a function f that depends on two others. Let us consider the following statement. Let's say that we have three functions, f, g, and h, and f of x is a function such that it finds itself between g and h for all values of x in an interval a, b. And let us consider a value c in such an interval. Then, if the limit when x goes to c of g of x is equal to a value L, and the limit when x goes to c of the function h of x is also equal to the value L, then the limit when x goes to c of f of x exists and is equal to L. Let us consider the following example. We have to determine the limit when x goes to 0 of the function x squared times sine of 1 over x. We can always use a table or look at the graph, but let us try to do this algebraically and use the squeeze theorem. We know that the function sine of x for any value of x will be between -1 and 1. If we multiply the whole inequality by x squared, we have that x squared times sine of 1 over x is between minus x squared and x squared. And the limit when x goes to 0 of minus x squared is equal to 0, as well as the limit when x goes to 0 of x squared. Therefore, by the squeeze theorem, we can assure that the limit when x goes to 0 of x squared times sine of 1 over x is equal to 0. Actually, we don't even have to know anything at all about the function f of x. Let's say that we have a function f of x that finds itself between 5 and x squared plus 6x minus 2. And we want to determine what is the limit when x goes to 1 of f of x. Now, if we use the squeeze theorem, we can get the limit when x goes to 1 of 5, which is a constant, and therefore it's equal to 5, and the limit when x goes to 1 of x squared plus 6x minus 2, which is also equal to 5. Therefore, by the squeeze theorem, we can determine that the limit when x goes to 1 of f of x is equal to 5, even though we don't know this function explicitly. It is important to remark that if by any case we want to find the limit when x goes to a of f of x by using two other functions g of x and h of x, in which f of x finds itself between them, then we can figure out those limits. But if those limits are different, we cannot assure anything at all about the limit of the function f of x as x approaches to a. In other words, we find ourselves in a narrow situation, therefore in a squeezing situation. So well guys, see you in the next video.